We're on 8th grade lesson 2.2. This is scientific notation with the positive powers of 10. And scientific notation is kind of a shortcut that is used, or a simplification process that is used when you're dealing with very, very large or very, very small numbers. In this case, for this lesson, we'll be dealing with very, very large numbers. Think about how awful it would be to have to calculate numbers if you were dealing, let's say you work for NASA, and you're dealing with space exploration and how distances would be. You would have some huge numbers that the calculator can't even fit. So scientific notation helps work around that. And then as we go into this lesson, you'll learn some tricks that have to do with exponents that those scientists would use in order to manipulate and solve for those numbers. So first part is just understanding what scientific notation is and how you adjust those numbers to represent it. So it really is just a movement of the decimal around, and if you look at this number, you notice it doesn't really have a decimal that you can see. And by now you've probably realized that even though I can't see the decimal here, there is one there. Anytime there's a decimal at the end of a number hidden, we know that it exists there, because if I had $250,000, I could also say that as $250,000 and decimal 00 cents. So we know that decimal lives there. So if you don't see a decimal there, you know it's kind of hanging out in the shadows at the end of the number. Otherwise, you would see the decimal where it's at. So if it's not there, it's hanging out, hiding at the end. Okay, so this is $250,000 and 00 cents. So I'm going to just go ahead and put that decimal there to show it up, because now it matters, because we're going to be manipulating this to move the decimals around. And in scientific notation, what I'm really doing is just moving that decimal over to a point where I'm dealing with like a single digit sort of a whole number. So I am going to shoot this decimal over all the way to the point where my front number, the very first number, is a number between 1 and 9, and then I put the decimal afterwards. So I have this 2 sitting here. So I'm going to move this decimal all the way in and move it here. And I know you're wondering, like, are you allowed to do that, Miss Sanchez? Yes, I am, if I follow certain rules. So it's going to go there. So it's going to look like a 2.5 now. And I'm dropping all those other zeros off there. I don't want to look at them. I don't want to deal with them. I don't want to type them into my calculator. Nothing like that. But the reason I'm allowed to do this is I'm going to tell people that if you really want to know what the value of my number is, then you're going to have to multiply it by 10 several times. And how many times do I multiply it by 10? Well, I moved it 1, 2, 3, 4, 5 times. So everybody in the world, if you want to know what my number really is, then you're going to take this 2.5 and you're going to multiply it by 10 to the power of 5. That's 10 times 10 times 10 times 10 times 10, which is really 10,000. And I'm moving that decimal back over that many spots. So this is just a shortened, abbreviated version of this number. And that is what scientific notation is you are moving that decimal, but announcing that, hey, by the way, I moved that. You got to add those back on if you really want to know what that number is. And so just the opposite can happen too. So sometimes I'm putting numbers into scientific notation if I need to work with them. Sometimes I might be needing to pull it out of scientific notation. So in order to do that, it's just the reverse really. I am looking at this 4.12. And whoever wrote this number this way in scientific notation is telling me that they moved the decimal 4 spots over to put it in scientific notation. So to move it back, I'm going to do the opposite of what they did and move the decimal 4 spots back. I'll put that there for first. So now it's going to go 1 spot, 2 spots. I need another spot. I need 2 more spots. 3 spots and 4 spots. And so what I find out is that this number is actually 41,200, put my commas, 41,200 is what this number really is in its standard form, and that's what it is in scientific notation. And so really, this just really takes a lot of practice going back and forth on these numbers. So we'll just do a couple of practice ones, and then you'll do the practice ones in your book, and hopefully that's enough. If not, hopefully I can help you a little more if it's needed. But here's another. We have in scientific notation 3.5 times 10 to the 6th power. So here's my decimal here, and whoever created this into scientific notation is telling us, by the way, I moved that decimal 6 spots in. So to undo that, I'm going to go ahead and move my decimal 6 spots out. So I'm going to go ahead and write it first, and I know I'm needing some spots here. And now I'm going to move that decimal 1, 2, 3, 4, 5, 6. My decimal goes here. This is a 3, a 5, and 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros with my decimal at the end. 3,500,000. And if I wanted to move that back into scientific notation, remember the steps are, I really want this decimal to be right behind the single digit number that's between 1 and 9. So I want it to move it all the way up to here after the 3 before the 5. That means I'm going 1, 2, 3, 4, 5, 6 spots in. That leaves me with 3.5. And I tell people, hey, by the way, I moved that 6 spots in. So move it back out again if you want it to be standard. So you end up back at that. So this lesson is just that manipulation of those numbers back and forth. All right, next practice one to see is we have 7.034 times 10 to the 9th. I rewrote it with some zeros behind it because I knew I was going to need several places, because this person is telling us in order to get this in scientific notation, they moved it 9 spots in. I'm going to move that 9 spots out again. 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. That gives me with this and 6 zeros. 7,034,000,000 is the number. Same number as that, just written in a different format. So one more example, we have 2.36 times 10 to the 5th. Again, this 10 to the 5th just means, hey, everybody to the world, I got this 2.36 by moving the decimal 5 times in, and I'm representing it here instead. So if we want it in standard form, we're going to move that 5 spots out. So I start by writing the number and then giving myself some room there, and I'm going to move that decimal 5 times back out again, and that gives me 236,000, 236,000. Same number written in a different way, and with practice it becomes easier.